All right, welcome everybody. Glad you're here. Glad we're back. Glad we have technology working finally. So today what we're going to be doing is we're going to be starting Learning Plan 2. And Learning Plan 2 we're going to cover over 2 weeks. So no problem, no sweat. We'll get through this just fine. And you'll find that in Advanced A&P that compared to General A&P, especially if you took General A&P in the summer, but if compared to General A&P just in general, the pace at which we cover things is much slower, but there's a lot more detail in that information sometimes. So today we're going to be covering the first part of Learning Plan 2. We're going to be going all the way up until top of page 4. We're going to start next time. Thank you very much. Appreciate it. See you later. Thanks, Jeff. We will end right before learning. Roman numeral number 5. That's a pregnancy on the mother. So next time we come back together next week, we'll cover from that on. So what we're going to focus on today is the whole process from fertilization through the time when the baby's ready to be born, essentially. So we're focusing primarily on the fetal development, I should say embryonic and fetal development today. There's not much to speak of for fetal development because once it goes from the embryonic stage to the fetal stage, you'll find out that it's pretty much ready to go. It just has to grow bigger and keep developing. So we're pretty much going to spend our time today talking about embryonic development, how the embryo comes to be and how it develops, how we go from a one-celled structure into something that looks remarkably human by the end of 8 weeks. So it's pretty incredible how fast it goes. So we're going to go through all of that today, and we're going to talk about kind of tying into what we talked about last time, hormones and how hormones are involved with pregnancy and the development of the embryo and so forth. So let's jump on into it. Let's just grab my PowerPoint slide here, and then we'll get started. Okay. Well, you know what's going to likely happen. I'm going to have to calibrate my board here. Spare me for a second. Sometimes the board has been doing that. They updated this board. Yep. And it just asks me to calibrate. Are you going to work with me or what? Bugger. Okay, well, then I'll just skip you. The heck with you. All right. Not important anyway. Okay, so when we talk about where it all begins, it begins with fertilization, obviously. And what we don't always realize is that the timing has to be almost perfect in order for fertilization to occur. So if you recall, maybe you don't recall, but I'm going to review it anyway. If we recall what we finished with in General A&P, which was the discussion of the ovarian cycle and the uterine cycle, does that sound familiar at least? You just finished with it, so it might be relatively fresh in your mind. Remember that we have the uterine cycle, which runs on a 28-day run, a cycle, and right in the middle of that 28-day cycle, compared to the uterine cycle, is when the ovarian cycle is when we have ovulation. So at day 14, that's ovulation. So up to that point, what had been happening is in the uterine cycle, the uterus has been getting thicker. The endometrial lining, the endometrium of the uterus, has been getting thicker and thicker and thicker and thicker and thicker. Ovulation occurs, and the uterine lining gets thicker and thicker and thicker and thicker. But it's kind of gets to its thickest point about the time when fertilization, if it were to occur, would be to the point where this fertilized egg would be ready to implant on the uterus. Okay, so that's kind of where we are. But ovulation is the key. So the woman has to, I should say, fertilization has to occur within 12 to 24 hours after ovulation. That's the window. That's it. And if fertilization occurs outside of that window, then the chances of her getting pregnant are much, much, much lower. So that's pretty incredible, right? That's a very narrow window. 12 to 24 hours after ovulation, that's when fertilization generally needs to occur. And then a lot of things have to go right or perfect in order for the fertilized egg to end up becoming a healthy, normal child. All right? So there are a lot of considerations. And when fertilization occurs, the sperm that fertilizes the egg, it's like winning the lottery, because in a typical ejaculation of sperm, there's 100 to 300 million sperm that are released into the female's reproductive tract. 100 to 300 million. And of those 100 to 300 million, only 100 to 300, period, make it to the egg. And only one fertilizes. All right? So it's quite astounding, the odds that are stacked against the sperm fertilizing an egg. What's that?
I've done that 4 times.
You've done that 4 times.
That'd be phenomenal.
I know, isn't it?
Here's our troopers.
So anyway, now you have to remember that the uterus. If you look at the anatomy of the uterus, you've got the. Come on now, you gonna work with me, or are you just gonna be a stubborn little SOB today? What's going on here? Why aren't you working with me today? I want to be cooperative. Let's turn this off and try turning on again. It was working just fine yesterday, but you know, I can't have a day, it seems, this semester where I don't have technology issues. Now, where's my little indicator saying that my pen is on? Where? Turn me back up. It'll be a long day if I can't use my pen. Let's try this guy. My secret stash. Responsive today. Oh, my thing moved. This is not cool. Come on, you little bugger. Get in me. How are you giving me the X here? Come on, buddy. All right, well, so much for that. So much for technology. All right. I swear, I'm going to have a day, one of these days, where my technology works as I want to all day long. All right. I apologize for that. All right, so I'll just use my little laser pointer. That's fine. All right, so what we see here is that the egg, when it ovulates, you may recall when ovulation occurs, it gets ovulated from the ovary, and there are these cells that are surrounding the egg when ovulation occurs. And these cells make up the outer rim surrounding the egg, and this is called the corona radiata. And these are the granulosa cells. So if you think of the follicle that erupts from the ovaries, you have these granulosa cells that surround it. It's kind of like a protective layer around the egg. And then you have another layer inside to that, which is called the zona pellucida. So basically what happens is, as the sperm gets closer to the egg or comes into contact with the egg, the sperm has to change itself a little bit in order to make its way down to the base layer of the egg and penetrate inside the egg to fertilize the egg. And so what happens is the sperm undergoes what's called an acrosomal reaction. And what that means is that the head of the sperm within it has enzymes. And those enzymes, well, I would say that the sperm starts to, the front part of the sperm head starts to wear down, and as a result, these enzymes are released. And those enzymes help the sperm get through this outer layer and start to make its way to the inner layer, which is called the zona pellucida. Also, what happens is when the sperm starts to get close to the zona pellucida, you can see here the acrosomal reaction. It's actually, the zona pellucida is actually going to draw the sperm into it. And then the sperm is going to undergo what's called capacitation, where it changes its swimming behavior. Instead of just being a straightforward swimmer, now it starts to change so that it's wiggling its head back and forth at a more vigorous pace to kind of burrow in and dig in through those layers. Finally, when the sperm gets through the zona pellucida, it will bind to some receptors that are here on the cell membrane of that secondary oocyte. And then what happens is we get a reaction. It's gonna harden off, or harden and close off the rest of this cell membrane so that no more sperm can fertilize this egg. And while it's doing that, the genetic information from the sperm is going to enter the egg, and it's going to merge with the genetic information from the egg, and we're going to see that we have the combination of the chromosomes, so that way we can get the full set of chromosomes. Okay, so lots happening here. So let's just back up a little bit. First of all, why don't you want more than one sperm to fertilize the egg? And it's not because you don't want a two-headed baby. What do you think?
Too much DNA to process.
Mm-hmm. Exactly. You hit it right in the head. Too much DNA. You cannot have more than 46 chromosomes to be compatible with normal human life. So you don't want an extra set of chromosomes. Okay, so that's happening as well. That's happening here. Now, there's also some things going on here that aren't said here, and I want to make sure that we talk about those things. Darn it, I wish I had my pen. I don't know why my pen isn't working, because then I could just write this up and it'd be so much easier to see. Darn it. Okay. Let's try something else. Let's see here. I don't think that'll necessarily work. All right, well, go with what I got. All right. So what we see here, which is really important, is that we say that the oocyte is going to complete meiosis 2. And what we see for meiosis 2 is that we're going to form what's called a second polar body. Let me show you here. I think I have some extra paper here. I'll do it this way. And a big stack of paper, someone took it. Nice, thanks. Not any of you. Someone who was in here yesterday said, oh, that's a nice stack of paper. I think I'll just take it. Okay, let me just this. Go. Right. Now the trick is I got to make it so that you all can see it without it being backwards. So I did that. We're good. All right. Okay, so meiosis 2. Let's talk about mitosis versus meiosis. We're going to be hitting this anyway in short order. Does anybody know what mitosis is?